Hello, everyone, and welcome to what seems to be shaping up to a bit of a sleepy day. Regardless of that, we are going to be trying to get rolling on some code again. Um, we may start on the new wall model, but first we have a couple of things to finish up and iron out. Before we get too much further into that, though, we'll check in with the kitties. It looks like Sammy is on the tree. We have Mason, Sky, and Ember on the bed. Molly is getting a snack and kind of giving a side eye to Sherbet, who is over there in the play area. There's a little chair seat support there that I don't know how they managed to drag it out from where it was, but they did. Hello, Sherbet. Did I mention you? Yeah. He has jumped up on the table. Hey, buddy. Yeah. Yeah. He's still very timid, but he does like to get scratches now and again. It's hard to tell whether he is going to lean forward or want you to scratch his back, or whether he's going to, cat liquid slide away. Oof. It would seem that he's going to traverse the chair first. Okay. So, last time, or at least most recently, we've been working on getting some dependency injection into the system. The idea of making it so that our code retrieves essentially services that it needs on the fly, and that those services are set up in a centralized location, which will allow us to both have a clean access point, a standardized access point, as well as a kickoff point for integration and regression testing kind of stuff, where we can set up tests that have like dummy services and whatnot to ensure that the basic in and out of a workflow is consistent. It has led to the implementation of a lot of interfaces so that we can access them as things that we intend to get, that we don't care that exactly what the thing is as long as it emits a time passed kind of model could be implemented. We don't have that right now. Most of the things are saying, I want a game object. I need this thing. So we'll just pop on in here. So we can start the game. The game does function. There are a couple of things that are broken, though. Like, the game does start. So enemies spawn. The basic bullets exist. You can see that the inventory does not. There are elements of it that aren't working. And if we stop the game and restart it, everything is super broken. Super broken. So we're going to be hunting that down. As well, we want to get our map model in, and we'll get just a little bit of a scribble here to show what we're looking at. So we're looking at kind of like at least for enemy flow, and to aid in wall collision, we're looking at kind of a flocking kind of pattern. A process where we're not looking so much at the individual, the ideal movement of an individual, so much as plotting out the movement of an entire swarm. This will have a couple of effects. So we're going to get our boundary in place. We're just going to use a red box for now. This is going to be the shape of the room. Bearing in mind that we can do things like this, and we will do things like that. Let's actually do something like that. And we're going to go in and find our little eraser here. Oh, well, that won't work. Our eraser tool, and we're going to make it big. snip that out. So let's say we have a room like this. Now we could have, as far as collision with walls, we could have what amounts to a series of, let's call them little like barriers. So we put one here. These need not be lines, bear in mind. We put one here. We put one across here. And so on. We have them all up and down like this. Just so. So this is one model for that. And what this would be is we plot out where we're going to place them, and that we have those barriers in place. Then whenever an object collides with the wall, we're going to intervene and say stop. There are a lot of potential flaws with this model. One of the big ones is that the things that really care about colliding with walls, the player, we want them to not be able to walk through a wall, and bullets we generally want to stop on a wall. But with enemies, we don't really care about the walls in the same way. We don't want enemies to walk through them, but we don't care about them like stopping on the wall. We want them to flow around them like a liquid. So if, say, the player is up here in this corner and there's an enemy down here, we want it to kind of slide around. So we could do, if there's an enemy here. Oh, wow, that's a teeny tiny line. What is up with that? There we go. If there's an enemy here and there's a player here, then we want the enemy to kind of go around and reach the player. We don't want it to pass through the wall. That would be bad. But it's not that it sees a collision imminent with the wall and changes its direction. That is excessive and also expensive, because I'm constantly having to, somewhere in the system, check for that overlap. Would I hit a wall? Or we're doing things like casting a line out and saying, does this bump a wall? Okay, if it bumps a wall, I'm going to have to do calculation to adjust my direction. With smaller numbers of things, that's perfectly fine. A lot of flocking algorithms will use that kind of thing where they sort of veer off of each other. But I don't want to have to do that, especially when we're worried about the entities running into each other. So if we take this same model and we're going to put our target right here. So here's our player. Here's our source entity. And this is the complicated part. This is the one that we really want to deal with. But let's say I already have an enemy that's standing here and one that's standing here. So the prior flow I can't do because I would run into these two purple dots. They're going to be doing their own thing, but let's just say this is like an enemy turret or something. It doesn't move. So now I'm initially seeing like, hey, I can go in a straight line, but I need to veer off and move along this way and then around and around again to get here, because I can't slip through any of those spaces. So we're looking at something like that. If I want to have that kind of flow, let's put you up above it. We'll hide you for now. So we'll put our green dot here again, just for reference. So we're looking at this. Now, the location of enemies doesn't matter in this pattern. Instead, what we're looking at is a series of, let's use this pink color. We're looking at a series of effectively lines where we say, okay, from this spot, I draw a line to the player. From this spot, I draw a line to the player. And we do that for every spot. So, like, from here, it's up like that. From here, it's over like this. And from here, it's up like this. But right here, when we're drawing a line to the player, right here at the edge, we're going to see that there are these surrounding spots where I can't go through these. I am adjacent to something I can't pass through. So we're instead going to have these little lines here where it's saying, oh, you need to go left here because you can't go in a straight line. I can see that there's this barrier in the way. And the same here and here. Paint is really terrible in a lot of ways nowadays. So we're looking at these individual directions and we're plotting them all out. Imagine these are like tiny squares, ultimately. Now we'll talk about how we intend to plot them out long term, but again, just imagine this is a grid and not just I'm drawing a line wherever the hell I feel like at the moment. So we plot this whole thing out here where we can see, hey, if you're sitting here, move in this direction to get to the player. As a bonus, we're also going to, in this same process, we're going to draw these lines that say, this is the direction of the wall using the same process. That if I look at this wall, if I happen to be in this spot, what direction do I go to get across the plane of the wall? So this flat surface here is the plane of the wall. It is, you know, like if the wall were a sheet of paper, that's its whole surface, you know, the 2D line. I want to be able to draw a line perpendicular to that. So we look at all the surrounding spaces and get that, like, okay, these three are open. I'm going to create an average line off of that and push in that direction and go in that direction. And we're doing that all over the place. We're looking at each space and saying, what is the raw direction either to an open space using the average of the surrounding stuff, or directly to the player as best I can. When it's looking here, it's saying, oh, the straight direction is here, but around me I can see a go down and left, go left, and it's going to push it until it's like veering away from that edge. So then when we put this in place, we can see some of that, where from here it's saying go up and left, from here it's saying go left, and it's going to loop around those purple dots. It's going to avoid the walls. So when I'm deciding at this moment, how does the blue dot move? I'm just looking at the map. Now, this has to be recalculated very frequently. Is the more accurate I want blue dot movement towards green dot to be, the more frequently I need to update this. But it doesn't need to be every frame necessarily. We don't necessarily need 60 frames per second player tracking logic. And this wall logic is static. Once I've calculated it once, it doesn't change. So I can always use that information. It's just this interior space with the pink lines that I would have to reuse. I have some thoughts on how to do this. We can do it with a variety of elements here. That once we have this base texture that we're using, this calculation is something that just needs the green dot and the purple dots. The purple dots would be wherever there is an entity. Such that it would create, this is a blocking space. Now there's fiddly elements to this, where technically the blue dot would be a purple dot. How does it know to get outside of itself, kind of thing? But if we know where all of the colored dots are, and we have the wall spaces, we can recalculate the pink area pretty swiftly, in the same way that you would be rendering to the screen with any sort of shaded surface. Because I'm going to look at it pixel by pixel and say, what do the surrounding pixels look like? What do the surrounding pixels out to X pixels look like? If they're big open spaces, then I don't have to worry about anything. If they're wall spaces, then I have to veer away from them. If they're purple dots, I have to veer away from them. So a force is applied to the direction that we want to go, so that we can start to shift around it. The distance that I look increases the ability for us to smoothly flow around things. If I only look directly adjacent, then I'm not going to notice the wall until I'm on the pixel that's next to it. The further out I look, the more likely we're going to get like fuzzier movement around some of these things, like we're going to turn late sooner than we need to. But the more easily we detect those. Now, when it comes to the bullet or the player, we can just say, where am I going? Oh, is it into one of the spaces that is, I am a wall vector that is just flagged accordingly? I contain a wall. If it is, then we say, okay, you can't go that far. Push back along the wall vector side until you're outside of it. There's limits on that. Like, it won't be the best indicator, but it will give us the idea of it like slid along the wall to some extent. If we are consistently moving in time slices that are small, like 1/60th of a second or 1/30th of a second, you're not going to notice the inaccurate parts here. Well, thank you, rules. Thank you. Let's blow up the image here. The ones you can see right now, left, right, top to bottom, are Mason, Sky, and Ember. The two biggest ones and the smallest one. And let's see, aside from them, we can definitely see at least one more. Okay. The only one that is missing right now is Molly. So, 5 out of 6. Don't know where she is. Sometimes she likes to tip over a clothes hamper and sit on the side of it. I was just going over kind of my general plan. My general plan for how we're going to map out basic enemy navigation as well as wall mapping. Will we get to this? I don't know. I do need to look further at shaders again as to how exactly I want to do this. The best way to actually get it in there, because we don't want to constantly update too much of the information. The more information that we have to give to the shader, the worse it gets. So what we might have to do is calculate what we'll call kind of brick red space here, which is all of this around the edges here. So we calculate that. That is going to again be average space that it's looking at. We only care about this space. We calculate this once for each room because this will be static. So now we have that image to start with. That image is going to be the basis for the pink space image here, which is all this stuff. Pink space is the navigation map. That is the kind of the liquid flow towards the target position. We recalculate pink every time green moves. Every time the player moves, we rebuild pink with some choice of frequency. Now, blue and purple also matter. In particular, purple matters. But we should be able to blend those. There is wasted calculation in that regard, is that we will map out the direction to the player as if there weren't purple dots. Then we will map out the direction to the player given the purple dots. Would be one way to do it. We'll have to see. If we do it cleanly, then we have a resultant texture, the one with the arrows. We have a texture that has none of the pink. The base texture has the green and the purple and the brick red built into it. We update the green and the purple each time. How to do that cleanly, that remains to be seen. Then what we can do is we can have this, like hypothetically, we could have this set up in a separate viewport sitting on a texture and make it visible whenever we want to update it. This is fiddly. We could do this as part of a compute shader, potentially just as good. But we need to make sure that we are as optimized as possible about getting the texture in and the texture out. Because every time we interact with the GPU in that way, it is a risk of memory shenanigans as well as cost to get to the GPU and back. That's why if we can get it on a visual shader, that is best, because the visual shaders are built in to run in that fashion. They're going to run as cleanly as possible. And if we have a very fixed algorithm with very few kind of if-elses about them, then we don't have to worry as much. We shall see. Beverage. But for the time being, close other tabs. Where do we have you? Services. So right now, part of our problem is that a lot of the UI elements are getting purged and aren't coming back. Some of these we do want them to purge out. Some of them we don't. So let's start from the Godot side. Let's close our scripts here. I don't want any of that open. We're going to run this. We're going to look at the debugger and see what's going on. Go here. We're okay. We start this. We're still okay. We stop this. We're still okay. We start this again. We have a problem. We have disposed a thing. Start game, load game. Okay. It's in core and load game. This is, we're saying get the game, but we have removed the game from the tree entirely, which will purge out the packed scene. So I think that's what's happening here. This is the first step in fixing this portion. Oh, Molly's under my feet. That's where Molly is. Molly likes to be directly under my feet, which always makes me very worried about the desk chair wheels, because she's like right up on the wheels. So I make it a habit of, before I move the chair at all, I put my feet down and like feel around for her. Hey there, NASCAR. Welcome. Okay. Load game. Load game. Where is load game? Here, and we run that. But first, we're gonna stop this. Okay, we start the game, we say resolve the game object. This gives us a game which is a node 2D. It exists, and it should continue to exist. We're making a game, NASCAR. At the moment, what you're seeing is Visual Studio, and as of this morning, Visual Studio 2026. They apparently released a new version. And we're debugging right now, because I did a thing that improved the overall, I feel like, maintainability of the code, and it broke everything. And we're still in the process of fixing it so that the overall maintainability of the code can be realized. Such as programming. Kind of a bullet heaven, kind of Vampire Survivors-y. We've got a lot of little things that we're adding to it. Thematically, it's related to my avatar and the background and whatnot. Okay, so we have the game object, we attach it, we attach that to the tree. When we unload game, we are going, oh, here we go. Right there. So this is okay, but when we do this, the one that's in the services, at the moment, NASCAR, we're building it to be as performant as possible, but a lot of the things that go into that can make it flaky on mobile. It should be viable for mobile. Our first target, though, is PC. That's a ways out, though. That's a ways out. This is our 160th stream doing this. Okay, when we do this, this will kill the node. Anything that still has a reference to it, we're going to have a problem. Okay, so now we know our weak spot is here. Okay. Do we got add? Scope, that's a universal type that doesn't go away. In theory, I feel like we want transient, so once everything's done with it, we should be clean. I feel like that's right. All of these should be the same. Okay, well that didn't make it better. Because the game object should be hanging out, is the thing. The core keeps a reference to it. Here. And we null it out when we unload the game, though. In theory, everything but catalog should be a transient state. Put you back, get rid of you, put you like this, put you here. Now, I don't. This is my first major implementation myself of a dependency injection structure, so there is a real good chance that I'm doing this wrong. But that hasn't stopped us in this entire project, because that is true of this entire project. So in the game object, we should be holding a reference to everything that needs to stick around. The entity manager, the world state, the catalog, the player state, all of these should be lingering. Right here. No lunar, no anti-gravity platformer yet. But a lot of stuff still busted, so it's going to be one of those streams. That okay, it's not the player state that's missing. It's that there is no player at this time. Okay. So we'll load up our game object here. Game. Under underscore territory. It's all in the ready that a lot of this stuff should be happening. Because everything about the game kind of exists only because of the game class showing up. Player state. We have a player now. Player state still exists. Entity manager exists. We have created the player object, but the entity manager doesn't have it yet. The entity manager should, though, have a entity to add, but it doesn't. As of this moment, it should. Right? We need base entity manager. Need my solution explorer to be visible. Ah, there we go. Had to find where they hid it. Load player. We get the catalog. We build the player. And we add the player. Starts here, we get to here. So if we look services, resolve entity manager, we get a thing. So we are going to step out, step in. Entities to add now contains that. And we wire up that entity. The initial loadout has happened. But there's elements of the UI that will have broken. Okay, so we did this. So we look at player state. So let's get this here again. Okay, I see. Okay, we can't do it that way either. We need a way to make these limited. Check something real quick here. Okay, transient is absolutely not what we want. Use a scoped lifetime. Patient type. Because we may end up needing to have a cleanup process inside them. So it's a singleton, but it has a instance marker inside of it. And that it knows when to clean itself up. well, it can be told to clean itself up, more or less. It's always resolve, but... that's the resolve method that we need to use. But resolve is just a wrapper around this. Ah, sneeze. We could create a scope. That would give us a scope. And we do that. Okay. 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 All right. So we would, for each game instance, we would add scoped values here. Because all of these are only relevant to a particular scope. And then we would dispose of it. But I don't know if this will do everything that we need. But it creates a pattern for us where when we're resolving, we can have a scope. And use that. Hired service, create scope. So yeah, we create a scope and then we dispose of it. And the scoped ones only linger as long as they are within that scope. So we would have ideally anything that needs to be fully limited to the game world is within the game scope. So we create the scope off of it, run through it that way. Now, we could build it to where each of these has their own thing. So when the game object is instantiated, it could go through and create a scope and say, I am going to instantiate these things. But we still want them to be within that scope. So it's only scoped things. This isn't ideal. I think we can make it work, but so I'm trying to think if there are going to be any other scopes. Well, even though you can't hear me, welcome, Will. We do try to keep things chill here. All right. It's not during the instantiation. Game entity. We are going to create a game scope out of that. Catalog is a full singleton. It always exists. Once it's loaded, it stays loaded. Public, static, void. So then we're going to have, in the same way we have our service provider, interesting. We'll just do service scope. We're winging it here. We're winging it here. If scope exists dot dispose theory, just nulling it should work, wouldn't it? We'll we'll start there. We can always rename these later. And the scope, if it's already there, start a new one. Okay, so these... These are all things that only exist within the scope. So this is services.begin scope. I don't actually have to do it before that, but these are all of the elements that are not yet actual services. They are things that have to exist in the world. We will eventually get them to not need to exist the way that they are. Process. Should have an on-exit tree here, but on end game, we are going to services dot end scope. Okay. Things exist. Things can cease to exist. Player can move. It still breaks if we restart, though. Let's look at it over on this side. Okay, and then we start, and we go back over here, and we have the same thing. So the game object has been disposed. By the time we reference it again. Are we keeping the game around when we shouldn't? It's right here. Game should be scoped. Now, is it possible that we're getting the same thing again, though? Okay, let's look at core, and when we unload game, so we have a node object, which is 3400. It will be unloaded. Okay, so that's not working how we think it do. Checking. Add scoped. Service scope factory, which we create a scope and we wrap it in that for doing a task. But we should have disposed the scope already. Okay, so we have game, and inside of game we should have... in again, we start again. Game is broken. Still. There is logic here that I don't understand yet. And that's a non-trivial part of this stream, is learning on the fly. Okay, we resolve game. That gives us a node object. That's what we want. We stop here. We are going to Why didn't we ever do end game? Well, that's not going to help. Ah, okay. Interesting. Game over exists. It's got to. Loading, game, ready. Game should be the one to contain game over. That is a screen within it. So we're going to hunt that, load game over. We pause the game. We get a game over from services, which we don't have. At all. So where are we getting it? That's extra weird. Because we're never hitting game over, that's why. Okay, there hasn't been a game over in a while because we haven't been triggering an end state. The end state wouldn't work. Okay, that's part of the loop that we haven't gotten back to, is the player can never die, so the game can never end, so we never get to game over. This explains part of our problem. So it is not here. It's not on end game. It's not perfect, but it really should be on exit tree. That's when we are going to do end scope. Once the game ceases to be, that's when we end scope. This is not perfect. Still not right. Scope exists. There are 5 scope descriptors, whatever that means. Okay, this is indicating that at the end of this, it should go away, but it might be that I'm ending the scope wrong. Yeah, I've got to be ending the scope wrong. quick break, then we'll be right back. Just a moment. Okay, we're back. Hello, buddy. All right. Research. Okay, it's when it's disposed. Service doing some reading real quick here. Just create the scope. Okay, we're kind of there. It's that because we're getting it from the original service provider and not from the scope, we aren't necessarily getting it from the correct, we're not getting one that will go away and be refreshed. So we need a pattern for that where when we resolve it, we want to get it from either the scoped one so when this happens, this is great, but the scoped service provider result if not scope dot service provider dot get service T. Okay, we don't know that that's nullable. Scope. Molly has joined me, so to service provider dot get service type T. All right. If scope does not equal null, else There is a risk surface here. But I think we're okay. We could create the scope immediately and just refresh it each time. Because ultimately, we essentially have state scopes. And that's primarily when the game is active, game scopes exist. Or the game scope exists. I don't like the idea of having core logic like this exposed. Or what happens if you have a scope in a scope? That could get weird. Yeah, our problem is that what service provider is varies based on scope. We currently need the service provider to create the scope, which I think is why there are these references to something called a service provider factory. Need to be careful here. Reading again. Scoped. If you're not creating a scope or within an existing scope, it becomes a singleton. Oof. This creates a problem. Okay. So, here. So this is saying, effectively, here I'm creating a scope. And I get the scope and I have a service that I can use. Great. It's a scoped service. Yeah, add scoped. So this service should be unique to its scope. But this scope is a singleton. This one is a singleton, and I don't want that because most of these things are static. Or effectively static. Oh, that's probably part of the problem. Let me look. it exists. It exists as a thing. We don't want it to be a singleton. We want a new one. That's not ideal, but it's... If we're doing it wrong, we're doing it wrong. We can't protect ourselves from us doing it wrong. We don't want nested scopes either. Oh, we have to be super careful with this. Scope.serviceprovider.getService T, just so. Otherwise, result to service provider dot get service T. Turn result. If there is a scope, we will use it. If there is not a scope, we don't care. Okay, we still have a problem. Problem still exists. I expect it's the same thing, just more so now. Okay, we need to make sure that we're only creating them at the time that we are going to use them in a scope. Game exists before the scope exists. Let's have the core handle this. In scope. Game, we do not begin and end scope. Stuff exists. Stuff exists. Okay, we have scoping properly set. We still don't have our inventory working correctly, but we'll get there. All right, all right. Do we though? Let's test something here. Should be here. Okay, the inventory is broken. So what I just did there, so mouse homing is working. I know there's an item that these are all clickable. So I'm going to grab this one and drag it to here. That will cause the weapon to be rebuilt, but it's breaking down. So let's look over on this side. We start, we look at here, no errors, pause, do this, release, look. No errors are happening. So we don't have a fundamental problem here. Okay. It is that the inventory is broken. So we need to find where we are doing that again. Player state. We have the inventory as a scene. So let's look at our base player state. We should have an actual player and inventory entity. So here's the base inventory, and then we have a the visuals for it. Extends inventory. It's a list of items. Do we ever instantiate this? Yes. So we iterate over that. Here, inventory UI is now going to be not null. Yes. When do we mess with the inventory UI? Got to be during the pause, but anyway. Item is the wind up mouse, and we do add it. Inventory UI, we've already initialized. Okay. We have empty items loaded in there. Hey there, Elman. Welcome. Ollie is sitting on my lap while I am trying to parse out where we broke the inventory. That is the last remaining part before we have most of the service infrastructure restored. Added all of the child objects here. So if we go into game, there should be a show inventory. Where we show the inventory. This implies that we're not getting all of the stuff loaded. We are getting most of our textures, though, so that's good. Is that we broke it somewhere else, or what? Molly is static balling her way across the desk. To block that off again, I'll have to figure out how. No, I don't trust you back there, ma'am. It's where the cables are. Okay, we go to inventory. That might be part of our problem. Oh, we're getting an inventory instantiated as a scene. Look at base inventory. We're going to be looking for here. Day is going relatively well. Relatively well. Okay, inventory UI drop. It is a valid space. There's nothing in from and nothing in to. We're going to go through, we clear all of our weapons. We get our catalog. We're going to go through all the inventory rows. Backwards, by the way. We're finally getting back to some coding, Ullman. We'll see how long it lasts, or how frequently again. Okay, the inventory is not sticking. All right, just a moment. Just a moment. I had to rescue the cables. One moment. Okay. Being a troublemaker, Molly. Yeah. All right. In our base inventory, this implies that none of this is ever sticking. Because if we never get here, that means that the inventory is not actually getting loaded. So this should be our inventory object, but not an inventory UI. An inventory extends node 2D, but the inventory need not extend node 2D. Okay. The inventory UI is purely for messaging purposes. It needs to get... Doesn't even need time passed. Okay. For now, it does. The inventory is... It is the non-UI player. So there's the player entity, which has health and all of that. But the thing that has, like, weapons and emits them and whatnot is the player's inventory. That's why it gets time passed. But it doesn't need to be a node 2D. And shouldn't really be instantiated or need any of this. It's that once it's created, it attaches to these by retrieving the relevant objects. It itself... Okay. It's not even game time passed. Yeah, it is game time passed. Yep. Okay, so one, to get this working, we need to make sure that this is even wired up. Okay, we add the child, which is the inventory. Is it that we're never getting an actual item that we recognize? Tracking stuff down, tracking stuff down. Welcome to debugging. It's the wind-up mouse. It does exist. So we're looking for the first available slot for a weapon. So we are going to set the value of this cell. Here, we're going to say it is this item. And then we're going to tell it that the inventory changed. This is the wind-up mouse texture. Okay. Step in here. Inventory UI exists. It is a canvas layer. We tell it that something has changed. Okay, and our row and our column 0, column 0. Does exist. Cells. Lists of inventory UI cells. Yep. These are the visual elements. It's already been initialized. Here, get player. Player state. When we're adding items, implies that the inventory is not what it should be. I feel like we should be updating inventory into an I inventory. Hey there, Lore. And get that out of the way now, because inventory is not, I mean, one, it should be the player inventory, just to be clear. Since it is heavily tethered to the player. But there's really nothing to say that it is, I don't really need to change the name, other than making it an interface. Since inventory inventory extends node 2D, but it doesn't ever really need to be added as a child object. Right here, we don't need that. We should just resolve it when we need to. A lot of these don't actually need to be kept as variables. Because we can just resolve them as we need to. The effectively get me the current entity manager thing. What you need to store and what you don't, and where you put it and where you don't, is kind of critical, because it's one of the things that will get your code very tangly over time. So we keep game over around because it is a object that will be a child. Anything like this is actually an object that we need to like pin to the world. Entity manager, world state, these aren't actually things. Only the game is currently really a thing. And in that way, it doesn't need to. That could be a game world node, which we use as a point of reference, like something that we give to the game, so that we divorce as much of this as possible from Godot interactions. Like, they don't have to be nodes wherever possible. It's like onReady can just be when we initialize it. Physics process can be that it listens to the core tick. A lot of stuff in Godot is already a ref counted kind of thing. Or I'm sorry, that's how Godot keeps track of that kind of stuff. Most objects don't actually need that unless they are explicitly a particular type of Godot object. See, when you have stored off the when you have removed the last of them, they just go away naturally. But if it's like a node, that's different. Yeah, we could move this outside of game and move it into the core loop, where, as far as the game is concerned, it has it's tracking accumulated delta and the like. That's what I mean, though, Laura. Most things already do that without you actually having to set them up that way. Like, if it's a resource or similar, you often have to explicitly free them to remove a reference count. But, like, a node, once created, still needs to be, like, let go. You queue free it. But if you're just talking like a class you made, those usually don't need to be a ref count. They go away naturally. It's a lot of stuff in Godot at its root is a ref counted. And declaring them yourself might just be making your objects more bulky than they need to be. You know, you're painting on another layer of a thing that it already does. But I would have to look at it further. I don't know in particular what you're doing, so. Enough said on that. Health UI is a visual thing. Inventory is not. And the inventory UI just needs to know about what happens here. We have a reference to inventory UI here, but it shouldn't actually care. We instantiate it, we initialize it. here we're attaching to it, we're getting the UI. Game we're instantiating as a game, and the game is a node as an object. But that, yeah, we can start removing some of this mess. All right, let's go. Let's break some more stuff. Interface, it does not extend a node 2D. It doesn't need that. It doesn't have a ready. So we need to set it up to do the stuff that it needs to do. And we will rename you to inventory. Must implement that. It must implement this. Must implement that. Add item show UI game time passed. Game time passed doesn't need to be up here. Or at least it shouldn't be up here. That is implementation specific. Don't call base here. So we do services.result. Plus equals okay, we have attached to it now. So this and this are done. And then show UI right here is our inventory UI where we're telling that you are not visible. But our inventory UI already exists as of this moment. But in game, I thought we already did that. No, right here. Inventory. Where are we messing with that? Well, happy birthday there, Glory. I hope you've been having a good day. The spawners. Okay, right here. This is where we're putting the inventory UI into the world as a child of the inventory itself. That's extraneous. That should be a separate thing. That should be a separate thing. Okay. Okay, so in services, right now, we're instantiating an instance of inventory UI. I'm sorry, we're not doing that in services. We want to be doing that in services. So we don't want this to be here. We want it to be a resolve. So service collection.add scoped. This is a I inventory, and we'll use base inventory. Services scoped. And currently we're going to say it's an inventory UI. And we are going to use just inventory UI somewhere here. Where is it? Base inventory UI. This we will change to an interface around something that is a node. Or I'm sorry, such that the node that is a base inventory UI implements an I inventory UI. So here we're saying, give me the inventory UI, and up in the game, we are going to do services.resolve inventory UI. Just like we do when we're getting the game object in the main UI. Okay, and that should remove the need for startup resources to have an inventory UI and an inventory. The more of these that we get rid of, the better. We're going to do a build here. What have I still left broken? There we go. We don't need to do that. Solve inventory UI. We don't need that to stick around. We can just resolve it everywhere we're touching it. Like right here. There, we don't do that there. We rip this out because we want to only reference it where we need it. So we have an inventory UI. Inventory UI is equal to services.resolve inventory UI. Just so we initialize it and we bind to an event here. Cell value. Do that in a lot of places, so we do want to set that up. This should effectively be free, so Not worried about doing that over and over and over. This is, we are purging it out entirely. That should be something that we can do entirely in the class initialize here. Is it Ishan? Yep, we periodically do coding streams. We're muddling through a game. We're using C# primarily with the Godot game engine. And we're making kind of a bullet heaven game. Right now, I am kind of breaking a bullet heaven game. It's pretty much right here. Saying rows and columns, and we set cell value. And set cell value. We are shifting over from kind of a bodged together dependency injection into explicit dependency injection, and it's resulting in some refactoring. So we are setting the inventory list, and we are raising the inventory change. This is where we're prepping it, so we should be able to do the same thing. Here. Okay. We initialize it. Oh, no, we would need to initialize it earlier and bind to it earlier. Yes. Okay. So. So in a base inventory, I am using Visual Studio Community 2026 right now. Up until today, it was 2022. Okay, when we instantiate that, we're all the way down here. Say inventory UI dot false. Let's make sure if there's a method I should be using for that. Is there like a set visible that I was using? It's part of the canvas layer. We'll do with that for now. Did I break it? I broke it. Okay. That is the inventory. This is the player inventory. So this is inventory, to surfaces. Yeah, it is real busy. One of the things I love about... So I learned to code in C++, and I have not coded in C++ for years and years now. And I'm happy about that. I don't like having to manually write up like my compile process or anything like that. I like being able to structure everything the way I want without having everything blow up in my face. Resolve inventory UI, inventory.add item. Getting there. Now, do I think it is valuable to know about that kind of thing? Yes. I think there is value there. Why is this not happening? Because the export never happens, which means we need to create the container manually. Yes. You can see some of my C background because of things like this. I'm happily past the point where I'm doing things like this. But the notation of a private variable has an underscore kind of thing. Well, tomorrow is a gaming stream, Ishan, if you want to see the other side of the channel. We've been doing a heavy investigative deduction game. But otherwise, I try to do this frequently. No. This button. Add child. I don't need to this it. Okay. The columns. Okay, this should probably break. Yes, okay. Okay, there's a show UI method that I should be using. Whenever we set it to visible is where base inventory. Inventory UI. Oh. No. The inventory has a show UI. Should be a broken segment here. Okay. Leave those alone. Break a few things at a time. Solve. Okay, closer. We need to reposition it. Okay. When I set up the UI in the game for the FPS thing, here. Set anchor offsets in preset. Okay. Base inventory UI when we are setting it up here. Let's double check. It's after it is already added. Let's see if it works this way. Okay, that anchors it to the upper left corner. It's not what we want. Okay, not quite. Where's the parent control? Set all 4 offsets to 0 after applied. The full rectangle. I don't want to have to deal with the margins here, because in game, if we look, let's see, how about keep height? Controls, layout preset mode. Center there. After we initialize it. Still the same. All right, research. Doesn't help me. There's got to be a cleaner way to do this. Should have a scene somewhere. as a label, which we don't care about. Focus, put, like, we can transform it to be in a particular spot, but what I don't want to have to do is actually find the screen center. Because right now, when I'm saying anchor it to if what does it inherit from? Inventory UI extends a canvas layer. What can we do inside of the canvas layer? Do follow viewport. Okay, there's nothing to play with in there. Is entirely based on grid container. In a grid container, say control, and we'll put you here. Not the first time I have heard that, Ishan. And I think that's good. It's, for a lot of folks, that just need a reason to start. And there are a lot of folks that don't realize that the best way to get going with any of it, even if you don't know what you're doing, is to just start. Just flail around a bit, you know? Exactly. I mean, it's the most basic tutorial, but Hello World's whole point is this is how you can begin. This is one of the simplest things you can do, you know? Center left of the screen. So if we look at center, it is actually locked center. Why does it not work? just need a color rectangle. Now we are going to oh. Is it a blender? I don't understand the question. We go into the game and we're messing with the FPS layer. Just out of nowhere here. Ah. I am not. Everything I've got is two-dimensional. I'm using a sprite as my primary visual editing tool. The UI that you were just seeing was the Godot editor. I use it only when I need to. Stats, we create a label. Never putting it on a canvas. No, okay, we make a canvas layer. Ooh. What if... this instead. Come on now. Same issue. Help UI is being helpful. It's already a canvas layer. We don't need to do that. This is a canvas layer, so this doesn't change anything anyway. Hello, Rogue. Hello. We are... I'm still trying to unbreak all the dependency injection stuff. And as part of that, I am trying to get the inventory UI to align properly. And it don't wanna. Horizontal center. Left center of the screen across the middle, or center of the screen across the middle. But that puts it there. Columns doesn't help us. Okay. Okay. (2D) rectangle. Get the size. Get rid of this. We're going to say center it. We're going to keep its size. Margin. This is not correct, but integer. Okay, we can see no impact. What did we do with the FPS UI? It's bottom left, keep its height. Give it a margin of 20, which I don't like. Okay, we can still work on this though. It's not anchors and preset. Just gonna say set position for now. Get viewport dot get. Is this real? What part? Oh, so hello, ni hao. Or ni hao. I don't know. Let me know. It's not a global position. It's not the visible rectangle. Not the window, that's for sure. Nope, not pre-recorded. We are flailing about in code live. It's not the camera. Because we want the canvas that we're sitting on. So like this dot. Get viewport. I think it's get viewport that we need. Hey there, Antium. So we get the viewport. Get visible rectangle. Just so. Okay. I'm making a bullet heaven style game, so akin to Vampire Survivors with some salt on it, you know? Trying our own spin on a couple of things, but okay, so we set position. We're going to need a vector 2. So new vector 2. Okay. And this is going to be... don't know if we want global position, but we're going to start with it. Size.x divided by 2 minus grid size dot size x divided by 2 comma. Right now what we're in the midst of, Antium, and folks, if it seems like I'm answering a question that you're not seeing, I'm probably talking to somebody in one of the other channels. But yes, what we're working on right now is refactoring the code so that I can do actual C# dependency injection, which will maybe help with some things? Question mark. Clear. Paste. No. Okay. Get viewport isn't getting us anywhere. Don't want to constantly do that. This only is valid after, so we can't get that yet. Like I was saying earlier, Nihal, the only thing to do is to start, you know? If we set its anchor to center and then we subtract half the grid size, let's try that. Here. That. Position. Yeah, it didn't do anything. Well, thanks for swinging through, Antium. I appreciate it. No. No, that didn't do a thing. So it's not until we have an actual tree that we have anything to see, and that's what's required for us to actually get the viewport and where we're looking. Okay, quick break. Be right back. Okay, let's see here. Doing some research. Viewport gives us nothing right now because we're not part of the scene yet. Oh, we have to be part of the scene. The inventory UI. It's important that we control where on the screen the inventory UI is placed. The player inventory is created. It's going to mess with the inventory UI, which will create that. We'll call initialize at that point. And in the base inventory UI, when we initialize, we're here, but this is part of a canvas layer, so we can have do ready here. We need container by the time initialize happens. If we take all of this, that up here, ready will mean that it's fully on the tree now. Okay. It's already not right. I can tell that. So this is us saying it's at its center. They're putting it on the center of the screen when we do this. So when we get grid size, we have a position here. Closer. Try set position. Okay, what we're getting is that it's centered, but we're getting the whole size of the grid here. So let's go all the way down to here when we get the rectangle for it. We're pushing it up and left, but it's like we're getting the whole thing here. Okay, this will get us the viewport. Instead of this, get viewport, get so if we assume that it's 0, so let's go through the math here. So this is where we're starting. Is this. Now, in theory, this should lock us at center when we do this. Okay. So then we are going to say minus grid rectangle for consistency. Size x divided by 2. Same thing as before, but the difference is that we now have a viewport. There we go. So now we have functionality again. This is more fragile than I'd like, but for the time being, I think we're okay. We still have to mess with the collision space and get that working properly again. But we are back to general function. We're still getting pretty good frames per second with this kind of nonsense going on. You can see a tiny little number in the lower left. That is the frames per second right now. Well, the upper number is visual frames per second. The lower number is the number of things in the world. Get some fun stuff out of this. Okay, so we got a little further so far. I think we've got most of this corrected. Like I said, I'm not real thrilled with the way that we're getting the UI put in place here. Because we do have a little wiggle as far as the initialize happening here. If the initialize doesn't happen, we don't get the grid container in place properly. So it is expected that you initialize it before you make it part of the scene tree, which can be a problem. It might be that what we need to do is that we need to actually have the inventory UI consult the the player service instead of having the player service assert against it. And I think that's, or the player inventory assert how it's supposed to initialize, because there's two separate pieces going on. There is the inventory screen loading up and having all the stuff on it, but there is also the inventory screen getting itself properly into the window. I think we're safe for now, though. We may have to revisit that kind of logic, though. But there's going to be more changes than that, aren't there? Just checking. I want to see if I can cleanly use... Okay. Yeah, should be fine. We commit that, and then we should be able to... Yeah. That, we're going to check and see if our local get has that properly. Yeah, okay. We'll deal with that later. I don't like... I like to keep Visual Studio as detached from like web services as I can. They don't need all of the service access that they want. Put another way, I just want an IDE. Stop trying to get your fingers in my data. Okay, we want to put this somewhere else. So there's two pieces here. This part is saying this is how many rows and columns the UI should have. So it puts itself together accordingly. The inventory UI, the actual base UI, is asserting what should be in those cells. So we do have a bit of a circular logic going on here. But I think that can actually be okay. Because right here we say, here's the inventory UI, and then we call initialize on it. But instead of this, we could consult what these values are. So in base inventory UI, instead of initialize being a discrete call here, we're going to move this logic here. So in our inventory UI, we are going to remove this initialize call. It's not going to like it. Right here. So we are going to say this is a protected method. And we are going to say our I inventory is equal to services resolve I inventory, and then we're going to call initialize with inventory dot base inventory has that. We're going to need to have a place that gets that. For now, though, as much as I don't like, we're going to put you here. And in our inventory UI, our base inventory UI, there's also a feeling that I have that I want to be able to manipulate the UI to give you like more or less space. Like add a row, remove a row, add a cell to the end of the row kind of stuff. A big inspiration for how the weaponry works in this game is Noida. And I want to preserve that, is the concept that the weapon you've chosen has like X slots. And a later version of it, you might be able to upgrade it to add another upgrade slot or another kind of module to it. We'll see how that plays, but effectively the visual inventory is ad hoc, where we are setting the rows and columns, or setting how we want to present it. For now, though, we'll just do it this way. Row. Okay, as soon as this comes into existence, we're going to initialize it with rows and columns. So in the actual base inventory, we are no longer doing that. So as soon as we invoke this thing, it is going to come into existence and resolve all of that setup. So we do need a way to, we still need a way to set some of these values. These are like our settings variables that need to be in existence before we get rolling. Okay, something's wrong. Where are we stuck? we have a loop going on. Okay, in the initialization of one, we are initializing the other. So if I go into this and I remove this here, yeah. So effectively, right here, it says to configure this one, we need this other one to resolve. But to initialize this one, we were initializing the inventory in its construction. Right here. Where we're going to say, I need the game, and I need its inventory drop to be pinned here. As soon as we did that, though, we were instantiating the other one, which was asking us about this one, which wasn't done constructing, so we would get another one. Repeat. So we do want to make sure that we minimize interactions between them when we don't need to. This is one of the tricky ones. Like this is the empty item. So this is an actual constant. I don't really want it to be, but it is. Okay. So we don't need to set cell here. It's already going to have that prepped. And it doesn't actually need to consult this thing or even this thing to determine what its variables are. It's only when this changes that we need to talk to this other one. When we do an inventory UI drop, instead of raising the event, we can have it assert that there is a UI change. So right here, we're saying on drop, we're saying from here to here, from to. So we can just tell it that. So we can just say inventory UI drop instead of it being an event. But I kind of still want it to be an event so that we can get that value. Which does mean it needs to know about it. It needs to be able to subscribe to that event. So for now, this is okay. But longer term, I want to make it so that it is the item in the row that you are setting that is determining the length. So we're going to need to dynamically mess with the grid. That upon updating the grid, we're going to look at it and say, do I need to change the UI fully? Do I need to reconfigure everything? Did I drag a weapon up or down is relevant. Right now, you can't do that. But we'll get there. It's accumulated delta here anymore. Because we need to avoid circular dependencies here. And as it stands, because we need to know when the drag and drop happened, or at least the UI cares when a drag and drop happens. We'll have to look at this more. Because I think it's safe to assume, like, we could say inventory UIs have, like, they have a drag and drop concept, but it's that what they're really invoking is that the inventory UI is telling the inventory something about the inventory changed. So it would say from to. But that still really screams that it's an event. So we do have kind of a loop here, is that when the inventory UI comes into existence, it needs to tether. Yeah. We'll work on that. We'll get more of that later. But let's see here. For the time being, I think we've covered enough ground for the day. So, as I thought, a lot of today was fixing the dependency injection. We did do some design chatter about how we were going to do navigation flow and walls within a room. We're still not there yet, but the idea is ready to roll. Exactly how we'll implement that, trickier. But I think we can get there, because ultimately what we're going to have is we're going to have a single texture that we're messing with, a shader over it, and footwork to essentially reveal that shader every time we have an update. But it's making sure that it's no more frequently than it needs to be, but frequently enough that we get the right behavior. Like, if we're getting physics ticks but not graphics update ticks, we don't want the flow diagram to stop updating. That kind of thing. Though if we're not getting graphics update ticks, we're probably not getting physics ticks either. But like, we want the physics to or the flow to update more than like 7 times a second if we're getting more physics ticks than that kind of stuff. So we'll see. We will see. But folks, I do hope you enjoyed watching with us today. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those buttons are generally good, so please press them. Train of thought derailed. If you'd like to consider financially supporting the channel, you can do so through platform-specific means, as well as other options that can be found through the link tree that is in my video descriptions and bios. With that said, though, I hope the rest of your day is good, and I'll see you next time.